survived the walk across the parking lot wasteland. I mean, they're very unusual as Brits. Welcome back to the afternoon session of NANOG 47 on Monday. I'm Mike Hughes. I'm one of the program committee members here. We're going to start off with 3 lightning talks, but before we do that, a couple of pieces of administration. First of all, if you have got an idea for a lightning talk for NANOG 47, we're still accepting submissions. You can submit later on today. You can submit right up to 7 p.m. this evening, and then the PC will vote on the lightning talks that we'll see tomorrow. Steering committee elections. Remember, this is your community, and what you have to say matters. So you can go and vote for the SC. All that's on the NANOG website, and you can vote up to 9:15 on Wednesday morning for that. So vote for the people that you want to run NANOG and steer things in the right direction. And then the other thing is the program committee nominations close for that this evening. So again, if you know anybody that's interested in being on the program committee, or if you're interested in being on the program committee, or you want to just nominate somebody who you think will be a great addition to the program committee, do that, because we really do need all the help we can get in the nicest possible way. So other than that, so we're going to go for lightning talks now. We've got 3 lightning talks. I'd like to get the first speaker up here, and that's Ernest McCracken, who is going to talk about real-time visualization. The idea with this is basically it seems to be getting lots of disparate data sources together and trying to do decent sort of coordinated stuff with it. What I'd like to do is get the next talk ready as well, so that we can move, because these are supposed to be pretty quick and tightly timed, 10 minutes each.
Hi, my name is Ernest McCracken. I'm a PhD student at the University of Memphis. I neglected to look at the location of the lightning talks. I actually thought that they would put me in a small room with maybe like 10 people to present to, so it's a little intimidating. If I mess up and say something completely wrong, please don't call me out on it. No, just kidding. So the work I've been doing, I actually started working on this in my undergrad, and it's called NetView's Real-Time Visualization of Internet Path Dynamics for Network Management. And the idea of the tool was to help both researchers and network operators visualize routing paths, and to help network operators and help researchers in developing future protocols. So the motive for visualization, Internet topology mapping and visualization attempts to graphically represent Internet architecture. And there's several examples I have here. Of course, CADA has done a lot of work in Internet visualization. There's other tools out there, Mercator, Rocket Fuel. And why to visualize Internet topology in real time, which is our main motivation here. So you want to monitor the reachability of a network. You want to identify anomalous depeerings, and you also want to identify route hijacking and misconfigurations quickly, so you can mitigate these effects or take steps to catch these effects. So we've been developing the next generation route monitoring software, high data completeness, integrity, scalability, and accessibility. We want the data to be accessible by everyone. So the first component, which was actually developed at the Colorado State, is called BGPMon, and it's a lightweight BGP monitor with over 70 peers, and it gives you this, presents this information in real time. Because other solutions like Route Views, I think it updates every 5 or 10, 15 minutes, and you can download the updates. And they actually make our work possible by giving us data in real time. And our component, of course, is called NetViews. Originally, it was just a tool to download the updates, and that was it. And then I was like, well, if we're getting this information in real time, why don't we visualize it also? And so we visualized AS paths, and then after that, it occurred to me, well, if we're able to catch routing updates in real time, why don't we also try to attempt to get the forwarding paths during these routing events? So just a quick look at the setup. So here on the left here, you have Did it show my pointer? Yeah. You have BGPmon, which connects to, actually we connect to BGPmon and they send us the routing updates. And from there, clients which subscribe to an overlay network, we forward the updates to them, and so they can get the BGP updates in real time, and that's through our data broker. And additionally, we have a probe manager that will probe the target networks to get the forwarding path information. And we actually probe the target networks from the BGP peers. We also have some smaller components of geocoder, which basically gets geographical information from the ASs, basically just office information, and an IP crawler, which attempts to get traceable IP addresses so we can have these ahead of time when we start our probing. And so just an example of our server component interaction. So in this example, 14041 has a route update, which is seen by AS3303, which is one of the peers connected to BGPmon. So the peer sends the BGP update to BGPmon, which forwards it to our NetViews portal. Of course, the data broker will then forward the update to the client, and the probe manager will connect to an LG Looking Glass server inside of 3303's network and probe the target network by issuing a traceroute command. This information is then sent back to the client so they have this information available. And we probe during routing events. So what we do is here's an example timeline of a BGP update is seen, and we initiate a probe right from the get-go. And periodically we will probe the same address until we see no BGP activity. So there's a various, you can see the BGP updates, but after a certain time period, we stop the probing and consider that the event has been completed. This is just a couple of the screenshots from a prototype, and you see a path to this -24. You can do searches and browse ASs and see the prefixes that they are originating. We also have visualization filters. You can filter based on, so here we're filtering based on the degree, basically the number of neighbors that AS is connected to. And we can see, for instance, this way, the ASs with the highest degree. And here I had a live view. I actually neglected to upload the actual video. Is it okay if I'm gonna go to YouTube to show you the video itself.
Ernest, should work.
Okay, cool. Should have done this beforehand, actually. Oh, let's turn that off. Add some nice little music there. And maybe you can go and help us break that 1,000 mark here. Yeah, yeah, everybody do it all at once. So just to show you, so this is a couple of updates, and the updates pop up real time, and they show it, they'll be displayed here on the map. And the locations of the autonomous systems are based on coordinates that we've obtained through the routing registries. And this is just a prototype. The actual interface and map have changed since then. And the blue paths basically are path additions or changes, and red paths indicate withdrawals. And let me pause this. Go back to here. And we can also visualize the forwarding paths. It's kind of a naive approach. Like I said, I started this in my undergrad, and there's, of course, issues with inferring topology from trace routes. So in conclusion, the features, we have a real-time visualization of the control plane, and we can also get the status of forwarding paths during route change events. And so that's where our work stands right now. In the future, we want to correlate forwarding and routing dynamics in order to create a classification model for network operators and researchers so they can see, classify different types of routing events, whether you're in a loop, routing loops, etc. We also want to add scalability because right now we're connecting to Looking Glass servers, which if we have 1,000 clients on at a time, that's not very good for those servers. So we want to add some scalability by having clients be able to run trace routes from each other in a peer-to-peer fashion. And that will help get more vantage points back to the same target network. And we also want to give client users the ability to communicate with each other using the tools so that you can communicate with others and talk about certain events that are occurring. And that is about it for me. Oh, also acknowledgments. We're funded by the National Science Foundation. And our collaborators are, we have collaborators at UCLA, Colorado State University, and the University of Oregon. And if anybody has any questions.
While we're getting questions, got to get Jim Cowie from Renesys up here, the next speaker, so that he can get ready to do his talk.
Hey, I'm sorry I missed the beginning of your talk. I was trying to figure out if you could YouTube. But that's very cool. I was wondering what it would require to run it, what infrastructure you need to run this tool.
Oh, actually, I implemented it all in Java. So we run the server portal in our lab. And clients, as long as you have Java on your computer, you can run the client. It's basically just a swing framework.
Oh, okay. So we could put a pointer up to it on route views or something like that. Yeah.
And I don't have the website here, but get with me afterwards, and I can give you information on looking at our research. And if any companies have summer internships, I'm kind of I'm in the academic setting, but I haven't had much experience in operations and in the field. So if any companies have summer internships, just let me know. I hate to plug myself there, But, thank you.
Okay, thanks very much. 10 minutes, perfect.
Which one's mine? Oh, that's embarrassing. Mine says company name here. How did I do that? Yes, here we go. All right. I'm Jim Cowie from Renesys. Sometimes, you come up with a great idea for a talk, and you go into the data, and the data gods give you material for a 30-minute talk, and sometimes the data gods don't smile on you, and they give you material for a 10-minute talk, and then it's not really fair to make people listen to a 30-minute presentation of a 10-minute talk. So this is the latter. The title here is The Recession, the Routing Table, Reading the Tea Leaves. So what Renesys does, you probably know, we peer with, 300-plus people, try to get the picture of the routing table as it's evolving, and periodically we dig into it and come up with some nuggets of wisdom. This is one such case. Here's what I wanted to know. Here's the great idea. I said, these are tough times. We know that the Internet responds in terms of the total transit marketplace to economic conditions, because we saw that we all got a bit of a break, a bit of a breather from V4 exhaustion immediately following the dot-com crash in 2000, 2001. So I said, oh, okay. There's a recession on now. Surely we should be able to see some signs of people retrenching in the global and regional routing tables. It makes sense, right? It's tempting. Enterprises are smart. They're rational economic players. You might want to scale back provider diversity, choose a cheap provider, maybe even leave the Internet. So as contracts are expiring or companies are going bankrupt, like hedge funds, we should be able to see the signs in the routing table. Nice idea for a talk. So do we, in fact? Well, so here's the curve I expected to see. Here's 3 years of the S&P 500 going down. It's come back. You've probably read about this. There's another curve that looks like that. Here's the Baltic Dry Index, which is a cool index that measures the cost of renting container ships to ship stuff across the oceans physically. Went right in the basement. 90% collapse. So 3 years of North American routing. I said it's got to go. Oh, I'm sorry, I have it upside down. It's actually like this, of course, because routing didn't slow down. It doesn't follow normal economics, it just kept going up. The amazing thing is the consistency of the rise. Too much gain. You know, it goes up. This is the North American curve, but you can look at the planetary curve, and it looks very similar to this. It goes up, multiple percent per year. Come hell or high water, there's no depression visible. Great, there goes my talk. So, you know, why does the table keep growing? Well, enterprises don't really cut costs by leaving the internet. Now, they may cut costs by reducing diversity or by putting off their plans to acquire more provider diversity. In an economic analogy, cheap transit and cheap address space is kind of like easy money. You just expect that with that kind of stimulus out there, with transit prices falling to single dollars per meg, you're going to get inflation in the table, and it continues. There's also the possibility that as V4 starts to run out, people may be wanting to put their assets in the table to show everybody that they're making great use of them. So let's take a quick look. Looked at the 1st of October, October 06, 07, 08, 09. Routing table goes up. I've broken it out here by how many providers each one of these prefixes had. And you can see from these rough numbers that a little hair more than half the table is actually just hanging out there with a single provider, which I guess is good news for the V6 transition. 29% have 2, and it goes down from there. One of the interesting things overall is that you see that the number of prefixes that carry 4 or more providers is going up. That's about the only healthy part that's really got a substantial growth rate. So let's take a look at each category just real quickly. Here you see a chart of the just the subset of people in the table who have one provider. Okay. So what this says is that from 06 to 07, 68% of those still had one provider. And the next year, 66% of those still had one provider. Sort of a recurrence. Some double-digit percentage of them sort of vanish into nowhere, usually because they are big piles of /24s that are not around a year later because they got reaggregated. Good job. And some small percentage of these guys go to 2 or 3 providers or 4, but you know it's not a lot. And if you look, as things go from 07 to 08 to 09, there are fewer and fewer people choosing to upgrade. Similarly, if you have 2 providers, there's a lot fewer of them actually going out to buy the 3rd provider as the recession kicks in. The rate of people going from 2 to 3 goes from 11% to 11 to 8%. The number going from 2 providers to 4 plus goes from 4.3 to 3.2 to 2.9. You can kind of see it dwindling, right? These are people, I claim, who are postponing the investment in additional providers, probably because of economic conditions. They're not leaving the internet. Mostly, they're not going to one provider either. They're just carrying on. Triply homed prefixes are kind of a sweet spot. They just renew. Some of them will bop down to 2, some of them will go up to 4, but usually they stay at 3. The interesting kind of thing here is the subset of highly multi-home prefixes with 4 or more providers. It's actually becoming a larger and more stable class over time. They renew. In other words, if you have 4 plus providers, you are highly likely to have 4 plus providers next year. You don't tend to go down to 3 to 2 to 1. And so really this is about where this idea ends. We thought that we might get some break. We thought we might see the growth of the internet slow down at least a little bit because of the financial train wreck worldwide. But I think cheap transit has killed that theory. As I say, there is some evidence that these 30,000 plus ASs that are out there that are being rational economic players and figuring out how to multi-home and what they're going to pay for next year, they're just delaying their purchases like we all do on big ticket items, on contractual items, when your future is a little uncertain. And as I say, you know, this is maybe not a bad thing because obviously we want to start weaning these 30,000 ASs off the idea that they can multi-home trivially after the V6 transition. They're going to have to sell for a lot less. So growth continues. And, you know, all I can say is bring on the V4 aftermarket. Because, you know, this is peripherally connected, but I think the stuff we heard this morning was pretty neat. Address space is valuable. Things that are valuable have a price. That price will either get discovered in the market or in the black market. It is better for all of us, I think, if that comes out in the light and we can regulate the market and get price discovery out in the open where we can all see it. It's my 2 cents. That's it.
Well, we have time for questions if there is any. And while we're doing that, if we can have Joe Abley up to the front, ready to do his lightning talk.
No questions?
I spy Randy Bush.
Yes.
Randy Bush, IJ.
Yes, sir.
Seeing as BGP is a brilliant information hiding protocol, and there are papers after paper which demonstrate that looking at BGP data from vantage point like RouteView's RIS and Renesys don't tell you much about the real topology of the internet. I'm kind of wondering how you judged somebody had only one provider.
Oh, it's not a value judgment, right? I mean, you could have a really good provider. That's all you need.
How did you judge how many people had only one provider? I'm calling bullshit.
Okay.
When you say...
Talk to me after.
Patrick Gilmore, Akamai. When you said provider, I assume you meant transit provider?
Yes.
So if somebody is not large enough to have, call it peering, even if it's paid peering or whatever, relationships with, say, the entire DFZ, then you have to be able to see that prefix through other providers. You have to see a longer AS path. They have to be announcing and propagating it, right?
That's right.
So I would call that not bullshit. I would call that science.
I can't add to that.
And the 10 minutes for that lightning talk are up, saved by the bell. Joe Abley is our next talker. Thanks very much, Jim.
Where is it? Down here somewhere?
The one where it says Abley Light something.
Oh, it's probably this one then.
Next one.
Nope.
So,
Where? This one here? Oh, that
down
one.
a bit.
Can't see properly. Apparently blind. How do I do
Control
full screen?
L.
Okay.
Everybody will know that Control L is full screen in Adobe Reader by the end of this.
All right then. So this is, I'm Joe Abley. I'm currently at ICANN. Matt Larson from VeriSign helped write these slides. He's not here. This is a slide deck which is too large for this slot. It was largely something that was presented at the Right meeting in Lisbon the other week. And so all the slides are here. I'm going to skip through a lot of them. The other thing that's worth mentioning up front is this is an informational update for people who know or care about DNSSEC. If you don't know what DNSSEC is, then there's not space in 10 minutes to teach you. So the project that I'm talking about is a collaboration between ICANN, VeriSign, and the US Department of Commerce. And there are various sort of marketing type phrases here. I'll skip over those. So the point here is that signing a zone with DNSSEC is typically something that an individual organization will do. The root zone is a little special for mainly political reasons. And so with the root zone, we have multiple parties involved in this exercise. And this really is the novel feature of this project, which is what I'm talking about. So the first role, the first organization is ICANN here. ICANN is managing the KSK, one of the two DNS keys in the zone. ICANN will accept the DS records from TLD operators. This is how a TLD sends its public key into the root zone so that validators can know to trust records in their zone. ICANN verifies and processes the request. ICANN sends the request to the Department of Commerce. So for those not familiar with the current unsigned chain of command in making changes to the root zone, this largely follows the same pattern. ICANN collecting information, US Department of Commerce authorizing it, and VeriSign publishing it. So in specifically with DNSSEC, the DOC will authorize DS record changes, which they don't currently do, DNS key sets, which they also don't do, and they also check that ICANN has followed the various procedures that they're obliged to follow when authorizing requests that arrive from TLD managers. VeriSign manages the zone signing key. They implement the changes that NTIA have authorized. They sign the zone, and they distribute the zone. So same as today, plus DNSSEC. So here's the same thing in diagram form. I'm not sure if you can see this. Same sort of idea. I won't dwell on it. The slides are on the webpage, I think, if you want to look at in more detail. So as far as protecting the KSK goes, in the X509 world, there's this concept of a CPS, which outlines and specifies the security practices surrounding key management. And for DNSSEC, we have this thing called a DPS, DNSSEC Policy and Practice Statement, and this is based on a framework developed by the .SE people. It's actually being pushed through the IETF as a publication process. So the DPS specifies all the things that anybody ought to need to know about in order to be able to audit the procedures that are carried out, or in order to gain sufficient confidence and trust for their own purposes that the procedures are adequate. And here is that in another nice omnigraphal diagram. So as part of this whole process, one difference from the way the X509 commercial CAs work is that we will involve community representatives in this process. So when we have key ceremonies in order to create or destroy or use the KSK in a secure facility, those ceremonies will involve third parties that are not ICANN, they're not VeriSign, they're not US government. So part of those people will have hands-on roles actually exercising crypto cards, smart cards as crypto officers in order to actually use the hardware security modules that contain the key material. Other people will have responsibility for smart cards, which are basically backup shares of the KSK, which are then distributed widely, so that in the event of a disaster, you can recover a KSK using those shares. We expect to have third-party auditors check that ICANN is following the procedures that we've documented. And we also expect the ceremonies to be open. We expect, if we are able, to actually webcast the entire ceremonies in real time. If for whatever reason that's not available, then there's certainly the video, the recorded video will be published shortly afterwards. So here are the technical details. The KSK will be a 2048-bit RSA key, which we'll roll every 2 to 5 years as a schedule, on that schedule. And emergency rollovers will happen, of course, whenever there's an emergency. We'll use 5011 for automatic key rollovers. And we will use signatures based on SHA-256. So there's an operational implication of this, which is that SHA-256 for use in DNSSEC has only very recently been documented. It's only just received its code point. And as far as I know, no shipping code actually supports this. So that might sound slightly ludicrous to go ahead with something that nobody can use, but at the same time, this does force every validator who actually wants to use a signed root zone to upgrade their software before they start, which might well be a sensible approach. The zone signing key, which is held by VeriSign, exercised by VeriSign, is a 1024-bit RSA key, and they will roll this 4 times a year, and the zone will be signed with NSEC, again with SHA-256 for signatures. The RSIG that covers the DNS key set in the root zone will be valid for 15 days, and it will be re-signed every 10 days. The RSIG records for everything else in the zone, which is principally NSEC records and DS records, and Apex records, will have a validity of 7 days, and those will be re-signed twice a day, and that frequency is because that's how often the root zone is actually generated. So every time it's regenerated, we'll re-sign. VeriSign will re-sign. As I mentioned, we will have key ceremonies whenever we have to manipulate or otherwise refresh the KSK. And we will exchange data between VeriSign and ICANN on a regular basis on this 4 times a year schedule in order for the ZSK to be signed by the KSK. So 4 times a year, VeriSign transmits a key signing request which contains a DNS key set and a requested validity period, and there will be a ceremony in which that is processed and signatures are applied by the KSK. So this is the slightly novel part, the way we split these operations between 2 organizations. ICANN is the organization of these 3 that will publish the trust anchor for the root zone. We plan to publish this in a number of ways. It'll be an XML wrap document and a plain DS record for cutting and pasting. We will also publish a PKCS 10 CSR. And the reason for doing that is that this is a format of key material that is readily used by existing systems. Also something that an existing X509 CA that you might already have some ability to trust can easily sign using the existing X509 infrastructure. So we are going to roll this out in a slightly conservative way. I'm going to go into more detail in the security BOF about exactly how we do this. But we're going to roll out the signed copy of the zone on one letter at a time, or a small number of letters at a time, starting on the 1st of December and then continuing until the following July 1st. I have a slide on this. So while we're doing this, we want to watch the traffic profile for these letters to try and find out what the reaction to deployed resolvers are to the large responses they might receive because they suddenly contain signatures. So we'll do this in an incremental fashion. And the other weird thing we're going to do is we're going to replace the keys in the root zone, which is initially deployed in this incremental way, with keys that are not published. So it's not actually going to be possible to validate anything in the root zone until we go finally live in July next year. So the whole purpose of this incremental rollout is to try and test and make sure that there's no network conditioners, middle boxes, anything else that's going to break in some dramatic and wholesale fashion because the response size that you received from priming queries suddenly goes through the roof. So if everybody suddenly on one day had to deal with UDP fragmentation and TCP transport, we might have a problem. This hopefully is a way of trying to detect these things early without breaking the DNS. So here's the timeline. 1st of December this year, the root zone will be signed. Again, signed in such a way that it can't be validated. The signed zone will be tested internally to start with. We'll start rolling this out letter by letter on the root servers. July next year, we will roll the KSK, and then the signed root will be fully deployed. So July 2010 is when a configured validator with an appropriate trust anchor can get to make use of DNSSEC for every TLD that supports it from the root zone down. And as I mentioned later on today, I have a larger slot to talk about this if anybody's interested in details, either from the operational perspective or the design perspective. One other comment is that the full documentation from an architectural overview, the DPS documents, the requirements documents that Department of Commerce provided that drove the design of this project are all expected to be released and made public sometime in the next few weeks. So not quite live yet, but hopefully in the next couple of weeks you'll be able to read all this stuff directly. That's it. Any questions now? Do we have a minute?
In theory, no, but...
Well, there's no questions anyway. So
and there's no questions, so great. Thank you very, very much, Joe. If you want to catch up with that ISP Security BOF, that'll be after the coffee break. Okay, so that's Lightning Talks done for today. There's another 30-minute slot for Lightning Talks tomorrow. The PC will accept submissions up to 7 p.m. tonight, at which point we will then select the three which will go on the agenda for tomorrow.